Okay, so let's take a look at Holt's method for linear trend. So this extends simple exponential smoothing to add a second smoothing parameter, beta, and a third equation, which represents our trend. So let's have a look how simple exponential smoothing has changed. So if you remember, in simple exponential smoothing, we had a flat forecast function, which was f of t plus h equals the current level. So in Holt's linear method, we've got this additional linear term, which is h times beta t, which is the current estimate of the gradient. So you can see that the current level is your starting position, and then as your forecast arrives, we're adding a constant value to that, so you get this constant increase in trend. We can also see that the current level includes this b term. So now we are smoothing all previous gradients by 1 minus alpha. And then the third component, the trend component here, you can see that the smoothing component, the smoothing parameter beta, is working with the difference between the current level and the previous level. So that's taking into account this change in level and trying to continue that on into the future. So let's put that in context with a concrete example. So we're going to look at US gross domestic product between 1920 and 2019. That's a very simple time series with a linear trend. That's going to be contained within the data folder in the gdpca.csv. It has an index column date, and it's got annual start frequency. So let's read that in and plot it. So here it is. So you can see that this has a linear, well, perhaps not a linear trend, but it does have a trend, particularly linear from this point onwards. So we can apply Holt's linear trend method using an exponential smoothing object. So the only difference from using simple exponential smoothing is when we call the constructor on the exponential smoothing class, we pass in a parameter saying trend equals true as well. So previously we only passed in the training data. Now we are passing in an additional parameter saying there is trend within this data. So we then call fit, and we then call get forecast to get our predictions, and then we look at our summary frame of our predictions, point predictions and confidence intervals in exactly the same way. So again, it's returned an identical object, a data frame containing the mean level, which you can see is now increasing, and our prediction interval for that point forecast going forward into the future. So we've gone forward 30 years here. So let's plot that. So here we can see that actually it fits it very nicely. There's not much noise within this data. And here's our projection going off into the future. And we have these gradually increasing uncertainty limits, prediction limits around that point forecast. So that was nice and easy. So it was exactly the same process as simple exponential smoothing in Python. We just included that additional parameter trend equals true. Let's have a quick look at the statistical model underneath that. So again, it's an ETS model, but now we can see we've got additive errors and additive trend within there, linear trend that means. And we can see that we've got a smoothing parameter here for our level of nearly 1, so quite harsh, and then smoothing trend of 0.2. And then we can see our initial level within the data where we start off, and our estimate of initial trend within the data. So not much of a trend to start off with. So if you remember, I said that we could include a damped trend within Holt's method and Holtz-Winters exponential smoothing. So I'm going to show you how that works now. Again, very simple. We just extend the constructor to include a third parameter where we say damped trend equals true. We would use damped trend because it's been shown to have some benefit in longer term forecasting. This is a 30-year forecast, so we should probably think about using damped trend. So all we're doing here is a bit of a shortcut. We're going to run, get our predictions, and then we're going to plot everything all in one go. So here is our prediction in red, our point prediction, and you can see that attenuates over time. And also our prediction intervals do the same. And in fact, our prediction intervals are wider with a damped trend. Let's compare that to here, where the prediction intervals are fairly tight. So that's Holt's linear method, which is a simple extension of simple exponential smoothing. It adds a second smoothing parameter beta for the trend, and it adds a third component which calculates the current trend within the data.